This section is on 4.5 rational functions. So this is part 2 of the video, and which is the graphing portion of it. So I'm going to walk you through on how to graph it. So to review, you need to find all the 3 asymptotes first. You need to do your vertical asymptote, the horizontal asymptote, the slant asymptote, because that's half the work. And then the other part is then to use all of that as your guiding point and then graph it out. Okay? So again, we'll walk you through. So the vertical asymptote is found from the denominator. So if we set the denominator right here equal to 0, it's going to be x minus 1 equals 0. So x is equal to positive 1. So remember, we also want an equation when we get to this part right here, because when we graph out the asymptote, it's going to become an equation. So now between HA and then also the SA, you're only going to have one of those. You can't have both of those. Now in some cases, actually, you may not have a VA, and the only reason you wouldn't have a VA is if you set the denominator equal to 0, and there's a possibility you will have to take a square root of something, and if it's a square root of a negative, then it's an I, right, because it's an imaginary number. In that case, you will not have a vertical asymptote. But most of the cases, you should have a vertical asymptote. And so then from here, once you have a vertical asymptote, then it's one of these that you will have. You wouldn't have all 3 asymptotes. Usually the most you would have is 2 asymptotes or 1 asymptote, okay? All right, so then from here, we have to decide whether we have an HA or an SA. So again, we go here and we do the comparison. And when we compare, we have found that the x squared up here is higher down here. So then if it's higher, remember then you have to have as a slant asymptote, because then you would have to do a long division for this, okay? So we have a slant asymptote instead. So when you have an HA that doesn't exist, just go ahead and put none. Please make sure you address it. If you put it 0, it's a number, so that means on the 0, that's an asymptote. So it is actually wrong if you put in 0. So don't put in 0. You're going to have to actually put in none, okay? So for the SA, since it's long division, we're going to have to work out the long division. So let's work out the long division. X minus 1 all over, let's see, 2x squared minus x minus 3. And just want to check to make sure it's in the correct power. So we have 2, 1 constant. Okay, so that works. So then from here, we're going to go ahead and say x times something has to give me 2x squared. So it's going to be what? 2x. So 2x squared right here. So if I distribute this right here, that should give us negative 2x. And then again, the operation is minus, so that cancels out. So that is negative 1 minus a negative 2. So this becomes a positive 2. So that should be a positive 1 then, because positive 2 minus 1 is 1. Bring down to 3, and then x, and since this is positive right here, we're going to go ahead and put a plus 1 right here. So that's going to give us x right there and minus 1. So then the x's will cancel out. And negative 3 plus 1 is negative 2. So then from here, the remainder we'll put down as 2 over x minus 1. And again, this is an equation of y equals. So when we actually graph it, it's going to be the 2x plus 1. So I'm going to go ahead and put SA right here as y equals, what was that, 2x plus 1? Okay, so 2x plus 1. Okay, so that's the graphing portion of it. So let's go ahead and sketch it out. So at x equals 1 right here, so we have an asymptote. Lightly do it. I would highly suggest to do this in pencil on the graphing portion, because you may not know what the correct final answer is until you have finished putting the table together. So let's see, 2x plus 1. So that means on the y-intercept of 1, I start right there. My run is 1 and rise is 2. So we're going to run 1 and up 2. So 1, 2, run 1, probably do another one, and up 2, so 1, 2, so somewhere around here. So here's the slant asymptote. So the slant asymptote, oh, let's go the other direction too. So you're going to run 1, down 2, so that's 1, 2. Okay, so the slant asymptote is something like this, and probably it would be best to use a straight edge to make sure it's correct on the line right there. Okay, so we have is this right here. These are your slant asymptotes. Or actually, this is the slant asymptote, and then this is the vertical asymptote right here. As we mentioned before, the vertical asymptote you cannot cross, but on the slant, there's a possibility of crossing. Now, this is actually now a guiding point, or I call it the fence, Because a lot of times what happens is then the graph, when you look for the graph, it's either going to be in certain pocket holes. So since the fence is shutting off from here to here, if you get a graph or points on this side, most likely it's going to come really close to this asymptote right here, and it's going to go something like this. Okay? If it's in this pocket right here, it's going to be kind of like a parabola shape right there, using that shape. If it's in this pocket right here, then it's going to be in this area right there. And again, you would use the asymptote as a guiding point right there. And if it's in this pocket right here, then again, you would probably have to use the asymptote really close to this and just kind of guide yourself right there. But we don't know exactly what it is, so we have to put a table together and then go ahead and substitute numbers in. So my suggestion on this is when you have a vertical asymptote, let that be the middle point that you're going to select. You may have to select a couple of other ones once you start those, because if you know what the points are, then you can stop. But if you don't know, then you're going to have to put in some more points. So since this right here, vertical asymptote is 1, I want to do like 2 on the left-hand side and then 2 on the right-hand side of it. Okay, so at 1, I'm going to go ahead and put 1 in the middle right here. So 2 on the left-hand side of 1 would have to be 0 and -1. So I'm going to go ahead and put 0, -1. And then 2 on the right-hand side, or 2 spaces on the right-hand side would be then 2, 3. Right, so that's 2, 3. Let's go ahead and label that just to make sure. And then this would be like -1. Okay, so then from here we would substitute these right here, these numbers back into the original. So we've done a lot of that substitution part of it, so we should be good with that. So now take this number right here, -1, substitute it in all the x's right here. Make sure you calculate the numerator first and then also denominator separately. If you have a scientific calculator that does all these parentheses, make sure you put parentheses, type it in, close parentheses, divided by, and then parentheses, type it in, parentheses. If you don't do enough parentheses, actually we'll give you a different number, so just be careful of it, okay? So to save time, I went ahead and did all the calculations. So the y is going to come out to 0 on this one, a 3. This is undefined because what's going to happen is when you substitute 1 into this equation, it's going to become 1 minus 1. So in the denominator, when you have anything divided by a 0, it doesn't exist. So we call it undefined. So this is the undefined. I'll spell it out for right now, undefined. So that means it does not exist, okay? So which is then this part right here is the undefined. It does not exist. So also, you have to be careful because sometimes the vertical right here is an asymptote, and also the vertical can be a hole in the picture. So I have an example of that one. So for right now, we just have is a vertical as an asymptote. Okay, so then 2 is going to become 3, and then 3 is like 9/2. So if you need to kind of pause on those videos to make sure all of your numbers are correct, go ahead and do that. Okay, so now from here, let's go ahead and graph it. So at -1 is 0. So at -1 is 0. So here's my first dot right there. At 0 is 3. So at 0 on the x-axis right here is 3. So that's 1, 2, 3. At 1 is undefined, which is this part right here. So that, yes, that works. 2 is 3. So then 2 is 3. So it would have to be somewhere around here, right? This is 3. Because I went 1, 2, 3. Yes, okay. And then 3 is 9/2. So 9/2 is what, 4.5? So it would have to be 3, 4.5-ish, somewhere around here. Okay, so I have 2 points on this side right here. So we mentioned it, this side of the pocket hole right there, the graph would have to come really close to that asymptote. So use that as a guiding point right there. So it's going to be something like this. And these are curves. So make nice curves, please. So we're going to make this kind of curvy right here. Yes, like that. Okay? So don't make this like L shape. That's not beautiful. We want curves. So on this same thing with this side right here, we're going to see that it's all on this side of the pocket hole. So we're going to go ahead and make nice curves. So it's going to be what we call a hyperbola. If you remember, hyperbola is kind of like a half of a circle. That's kind of what the hyperbola is right there. Okay, so then all of this is the graph. This part should be the darkened piece right there, and then the asymptotes are the light piece. So make sure you do this in a pencil because if you make a mistake, it's kind of hard to erase it in pen. Okay? Now, let's take the next example. So doing the same thing. So we have is x plus 3 divided by x squared minus 9. So the vertical asymptote, we're going to set this equal to 0. So if I set this equal to 0, I'm going to have is x squared is equal to 9, right? And then x is equal to plus and minus 3. Now, vertical asymptote is plus and minus 3. This is where I say is where you have to be careful because it's a possibility that at plus and minus 3, 1, 2, 3, that one of these can be a hole in the picture, and then one of them could be an asymptote, or both can be an asymptote. So I'm not sure for the moment, so I'm just going to go ahead and make it as an asymptote right here. This is where you need to do it in a pencil. But unfortunately, I have a pen right now, so one of these may have to turn into a hole, so we'll see. Okay, so you could just go ahead and start off with those. Then you can do to see if you have an HA or an SA. So remember, we do that comparison right here. And when we do the comparison, we find that the denominator is larger than the numerator. So this is definitely an HA, but an HA of y equals 0, right? So y equals 0. So this is none. So at y equals 0, again, that's the unfortunate part, is it's actually up here. We won't be able to see it, but for now, I'm just going to go ahead and just put it a little bit above it so you can see that this is going to be an asymptote right there. Okay, so then again, this is where the holes or the pockets become. You have a picture on this side that it's going to divide. It's either going to be up here, something like this, because it's a guiding line right there, or it's going to be down here instead. So same thing on this edge right here. It's going to be something like this or down here. So you have to figure out when you do your calculation, is it up here or down here? Is it up here or down here? Now, if you have two vertical asymptotes in the middle, you have usually two choices. It's either an S shape or it's a parabola. So also the S's can either go this direction or it could go the other direction. So this is where you need to make sure you have enough points to do that. Or you can have a parabola that's upside down or a parabola that is upright. So there's only two shapes on this one, but within the two shapes, there are actually technically, four choices because they could flip on the other opposite ends, okay? So let's go ahead and then, again, use some numbers. So since -3 right here is kind of like the asymptote, I'm going to go ahead and pick two numbers before it and after it just to make sure we have enough. So let's see, what's the number that we want to choose? So we have as -3. Let's see, we're going to go -5. Okay, so -5, -4, -3. Okay, so again, this is -4, -5. Then we want to choose like 2, 1, and 0 probably, right? So we got it 2, well actually I think I chose 0 and 1. Okay, and then we have to pick then more points on the other side. So after 3, we want to put like 4 or 5 probably. So we have, now I'm going to have to create this somewhere over here. So let's see, 4, 5. This is going to be still my X, and this will be Y. And then we may have to find that we may have to do more points on this, so we'll have to figure that out as well. Okay? So when we substitute this -5, again, back into this original equation right here, the calculation should come out to something like -0.125. Calculations for -4 would be 0.14, but negative. At -3, we said was undefined. At 0, it's going to be -0.33. At 1 is -0.5. Then at 4 is 1. And at 5 is 0.6. I'm sorry, 0.5. Okay? So now we're going to go ahead and graph it. So at 5, we said was -0.25. So that's really, really close to that 0 line, but not quite at 0. So we're going to go ahead and put that really, really close to 0. At 4, -4, it's -0.14. So it's a little bit further away from this previous one because this is 12 basically and this is 14. So it's a little bit off from there. Then we don't know what this is. It's either going to be a hole or it's an asymptote. So if it is an asymptote, then we definitely know that the picture is going to be this direction right here. Okay? Then we have is -2. Oh, so I'm not quite sure what -2 is going to do. So let's go ahead and actually put in negative 2. Negative 2, I think the calculation comes out to negative 0.2. So at negative 2, negative 2 is just below that as well. So it's a little bit lower than that, I think, right? So maybe a little lower. Okay. And then, did I choose negative 1? No. So let's do negative 1. So negative 1 is about negative 0.25. So then again, that's a little lower than this, just a little barely. And then at 0, it's negative 0.33. So again, that's a little lower than that. Then at 1, did I choose 1? Yes, negative 0.5. Okay, so it's going lower than that. Then at, did I choose 2? No. Okay. So here's the thing. You could see that the graph is actually going consistently lower, 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 lower right here, right? So eventually this 2 right here, if you go ahead and substitute that, it should probably be somewhere down here. So what happens is this negative 3 actually is not an asymptote. It's actually a hole in the picture. Because what's happening is it's going to go like something like this, and then you're going to have a hole in the picture, and then it's going to continue on, and then go downward something like this, and use the vertical asymptote. Now, the reason why I know that is because if this was a vertical asymptote, what happens normally with the picture is it would be like this down here, and then the next number you would choose at negative 2 would probably start up here instead. So usually they're opposite ends when they start. So that's how you know that you have a vertical asymptote for that reason. Okay, so but if it looks like the numbers are continuously going downwards or upwards, then most likely that's going to be a hole in the picture right there. Okay, so then after 3 we have is what, 4 and 5. So 4 we said was 1, so somewhere around here, and then 5 is 0.5, so that's smaller. So we can see that in this picture right here, it's going to go something like this, right? So it's going to be above this horizontal asymptote. Make sure it's above it, but not crossing over it right there. So here we are at the horizontal asymptote, okay? So this is going to be the picture right here, where you have this part right here, and then you have this part with a hole in the middle, and then it continues on right there, okay? So that's another type of the graphing. And then I'm going to do a third type. So the third type right here is the same idea. We have a vertical asymptote down here. So when we set the vertical asymptote equal to 0, it's a quadratic equation. So you can do either the big X method or the binomial factoring, etc., right? Or the quadratic formula or completing the square. So, oops, this is AC. So AC is negative 3, and then B is negative 2. So the number combination of negative 3 is negative 3 and 1. So 3 and 1. Right, so then that gives us negative 2. If we add those, if we multiply, it becomes negative 3. So that works. So if I put in parentheses, minus 3 plus 1, and then again, make sure you don't have an A number right here, because if you do, you would have to put that A in there, and then you would divide it out. But in this case, it's 1, so we're good. So x equals 3 and x equals negative 1 are your vertical asymptotes right there. So that vertical asymptote, x equals 3, and x equals negative 1. Okay, so then from here, do we have an HA or an SA? So if we compare this part right here, the numerator is smaller than the denominator. So you have then is an HA, and HA in this case is 0 because this is bigger, right? So then it becomes y equals 0 again, and so SA is none. Okay. So now let's go ahead and do the graphing portion again. So again, we don't know on the vertical asymptote if it's a hole or if it is two vertical asymptotes. So for the moment, you would just do lightly. So at negative 1, so somewhere around here, I would just lightly graph that out with your pencil. And then from here at the 3, so 1, 2, 3, we'll graph that out as well. So one of these can be a hole in the picture or both being in a vertical asymptote. And then y equals 0. So again, it's right above this right here. So it's going to have to be above it. Or it could be below, actually. But just make sure then you're consistent on that one. Okay. So now let's go ahead and substitute numbers in. So let's go 2 on the left and then 2 on the right as well. So this is 1, we said negative 1. So from negative 1, we have like negative 3 and negative 2. So we want negative 3, negative 2, negative 1, because we know that's going to be an asymptote or a hole. And then we want something like probably what, 0, 1, and 2. So we have a 0, 1, and 2. And then after 3, we have is 4 and 5. So we have is 4 and 5. Okay, so then again, we go back and substitute this back into the original equation, which is all of this right here. Make sure you put parentheses when you put it into the calculated portion of it, or calculate it separately. So calculate this part and then calculate this part and make sure you divide it out. Okay, so I did the calculation and it comes out to 0.33, 0.6. The negative 1 is the undefined, so we have to check to see if that's a whole or if it's an asymptote. At 0, it's 0.33. At 1, it's 0. Then at 2, it is, let's see, what, negative 0.33. At 4 is 0.6. And then at 5 is 0.33. Okay, so we're ready to now graph it out. So at negative 3, negative 0.33, so it's somewhere that's really close to 0, but not quite 0 yet. At negative 2, 0.6, so it's a little lower than this previous one, so a little lower than that because it's about a little more than half, right? Because half will be negative 0.5. So at 1, it's undefined. So again, it could be either in this hole right here, or it could be like the previous one. It just continues on and uses maybe up to here. So you just have to be careful with that one. So let's see, at 0 is 0.33, but it's positive 0.33, notice, right? So it's up here. So most likely then this picture, we're done with this picture right here. This is definitely a vertical asymptote because it jumped up right there. So we're going to go ahead and continue on and then just use that vertical asymptote. Remember, we can't cross the vertical asymptote, so that's why you have to have a hole or it just becomes part of the picture right there. So at 0, we said was 0.33. At 1 is 0. So here we have is 1 is 0. At 2 is 0.33, so it's below this right here. Okay, so now looking at this part right here, remember I said it's either an S or a parabola. So can we see that it's probably going to be an S shape because this is going to come this direction right here, and it's going to go through here and make that S shape right here. Okay, so let's use that then. Use the asymptotes, really get close to it, and it's going to be a nice curve because it's an S shape, right? Something like this. So if one of these points, let's say like this point was here, up here, then you know for sure it's going to be a parabola like this, right? Or if this point was on the bottom right here, then you knew that it's going to be a parabola shape right there. But since they're opposite ends, that means it's going to be most likely an S shape. Okay, so you have to be careful, and you have to have probably like 3 points in the middle somewhere just to make sure you know what the shape is. Okay, so then let's go 4 and 5. So 4 is 0.6, positive 0.6. So again, somewhere up here. And then 5 is 0.33, so it's below that. So something like this. So since it's above in this area, so most likely we're going to go ahead and get a nice curve or hyperbola shape, which is this right here. Okay? So then this becomes your final graph right there. So there are many different ways to do this, so make sure you go through each one and you know what you're looking for. Okay, go ahead and now do the classwork.